Welcome to the next important vertical in this course, that is group technology and computer aided process planning. As the name clearly insists that it is called as group technology, that means to say you are supposed to group something together based on some similarity. So, what is that similarity as far as a part is concerned? It can be shape, size or the manufacturing process. So, grouping parts similar to features what is there in the product or in the part is nothing but group technology. This is very important, because as and when a part enters into a factory or into a design, we have to give a number to it. How are we going to give a number to it? That is what we are going to see in this group technology. After understanding the concept of group technology, we will be moving towards process plan, and wherein we will see manual process plan. And today, because of the advancements in computer, how computer is getting integrated into process planning today. Computer aided process planning is a very important topic, because this is what going to club between a CAD and a CAM environment. CAD is basically a designer who draws. It can have conceptual, it can have embodiment, it can have detailed design. Now, after that, when it has to go for manufacturing, computer aided manufacturing, it has to have an interface which understands the drawing and converts the drawing into some form such that it can be produced. So, that interface will be done by a process planning, and we will study here how computer is helping in process planning, because this course wholly goes around computer integrated manufacturing. How do you integrate computer into mass production, into mass customization, into batch production? So, that is what is it. So, this is a very important topic. So, the content of this lecture will be, first we will try to see what is group technology, then naturally the benefits or the advantages of group technology. We will see what is a part family, then coding system, then limitations of group technology. Part family, those of who are studying science, they will really appreciate. In botanical studies, you have so many plants. Now, all these plants, what we do is we try to group them under some commonality, and that common name is given as family. So, in the similar manner, the manufacturing industry also has taken the logic from botanical scientists and zoological scientists. They have come up with how do we make families such that we can integrate different versions of parts into one grouping and then start understanding the grouping. So, what is group technology? Group technology is otherwise called as GT, is a manufacturing philosophy in which similar parts are identified and grouped together to take advantage of their similarity in design and production. Similarity in design can be size, shape. Production can be a manufacturing or a machining process. So, here group technology is to identify and group together to take advantage of their similarity in design and production. Group technology contributes to the integration of CAD, computer aided design, and CAM, computer aided manufacturing. This is what I said. This is going to bring in, this group technology is going to bring in a seamless connection between CAD and CAM. Similarity among parts permit them to be classified into a part family. This is what I gave you an analogy of botanical families and zoological families. They look into the similarity whether the animal has 4 legs, 2 legs, mammals. So, they put under families. Why? Because once you put them under a family, you can generalize and talk about their family characteristics. Same way here. Okay. In each part family, processing steps are similar. The improvement is typically achieved by organizing the production facilities into manufacturing cells that specializes in production of certain part families. So, you have grouped those families in botanical studies and zoological studies based on some similarity. So, here also we will do that either with size, shape or in terms of manufacturing. Why is this very important? Suppose let us assume you are trying to find out a new plant, a new animal or a new product coming into existence. Then what you do is you have to quickly grow, cluster them and put them into some family. Why is that important? Because once I know they belong to this family, their characteristics, their machining process to a large extent I can understand, and this if I have to automate, it becomes very easy. So, part family is a very important thing which is done under group technology. So, group technology has all these things integrated into it. It takes costing, R&D, quality control, IR, industrial relations, estimating either in terms of time or money, tool engineering wherein which we talks about jigs, dies, fixtures, okay, then gauges for measurement, maintenance, predictive maintenance, preventive maintenance, data processing, design engineering, we look into sales. All these things get input from GT towards that. So, sales, inventory, planning, this side is completely resource planning. So, all these things get input from group technology. So, planning, purchase, assembly, management, manufacturing engineering and shipping and receiving. So, all these things by and large try to get information from group technology. What are the benefits of group technology in manufacturing? It allows similar designs to be easily modified from the existing design. So, if there are some 6 people, so all these 6 people, if you want to find out some similarity amongst them, suppose you have a class of 40 students and you want to talk about the class. So, if you want to talk about the class, one you can talk in terms of health, then you can talk in terms of IQ, then you can talk in terms of EQ. So, when you do that, what you do is you conduct an exam, normalize it and then you try to figure out what is the strength of that particular classroom, the students in that class. So, then accordingly you can put a teacher who can teach them and try to improve what is missing with them fast. So, that is what is done here. So, it allows similar design to be easily modified from the existing design. So, there are a lot of data, you are trying to group something common data into one family. From the database, instead of starting from the scratch, I told you example, a new part comes inside, a new plant comes inside, then how do you classify them and how do you talk about their characteristics? Standard process plan can be developed from the grouping. Once you have grouped them, for after grouping them, I can have a strategy such that these are the processes which are to be used if the data is like that. That is what if you go back to a similar analogy of a classroom, once you know the classroom is lagging certain properties or certain intellectual capabilities, then you appoint a teacher to cater to those only and then uplift them. But whereas when you try to talk about in manufacturing, what we do is we try to make a standard process for them. Moment you standardize a process, then for that standard process, establishing a layout inside a factory becomes very easy. So, grouping those machines become very easy. So, once you group a certain machines, then manning those machines becomes very easy. So, we will always look for standard process plan. So, that comes out of group technology. Then great efforts can be applied in optimizing the process plan. Optimizing process plan is very important because you can now quickly take a stock, what is the raw material required, what is the shape of the raw material required, what are the tools required and what are the dimensions of the tools required. So, process plan can be optimized. Then tooling and setups, standard tools can be developed, then allows faster production, therefore lesser inventory and work in progress. The throughput time can be reduced to a large extent. Material handling and movement is also reduced. Moment you know that these are the machines to be used, now I will arrange those machines in a particular fashion such that the material handling becomes very easy. See, when you talk about big industries where there is a mass producing or batch production industries, material handling is a big challenge. Can I move part by part? Can I move 30 parts? Can I move 100 parts? Can I move 1000 parts? It all depends. For example, when we try to take a soft drink which gets transported from the wholesaler to a retailer, now it depends on what is the packaging you do and now how do you handle the packaging. So, material handling is very, very important, and movement is also unnecessary. Back and forth movement is reduced because any movement which is redundant in the factory is going to put a cost on the factory. For all these things, group technology comes up in a big way and gives a big shift in productivity in the manufacturing scenario. Apart from those benefits, it also tries to improve the quality and reduces scrap. Utilization of the machines have been increased. Floor space available is also increased. Increase in the output per employee is also done. Then manufacturing lead time is reduced. Then you will have improved ability to respond to customer, to market. So, the agility, depending upon the market requirement, variation in the products can be done very fast. So, agility can be done, job satisfaction is done and greater management worker harmony can happen. So, all these things predominantly goes to the benefit of group technology. So, group technology implementation can be split into 3 phases. First, action on the manufacturing process will be the first phase. Changes to the production process will be the second phase. Results for the organization will be the third phase. So, these are the 3 different phases which all happens during the group technology implementation in a factory. So, when we talk about group technology, the following actions on the manufacturing process has to be done: part simplification, process standard and production control. 3 important actions are to be taken. Part simplification. Suppose if there are variation, if there are 100 number of variations, so what we do is we try to simplify and try to make the part geometry modular and simple. And what we do is with that simple thing we will see how do we functionally meet the requirement which is expected out of the product. Next, we try to process standardization, we try to do it. Rather than doing everything on a firefighting mode and erratic mode, we establish a standard procedure and follow it. For example, between one machine to the other machine, 50 parts is the minimum size of batch size which is to be moved. Then for example, the layout of the factory can be standardized. Next, the production control. The changes group technology can have on the production process are tighter part control, close physical layout of machine groups, ordering tied to production. All these things can be done if group technology is implemented in a strong manner. Tighter part controls can be done, close physical layout of the machine groups and ordering tied to production can happen. So, different impacts group technology has on the production process. It reduces purchasing cost, redundancy is reduced, accurate cost estimation can happen, quicker design changes can happen because you have standardized the part. So, when there is a small change you have to do some modification on the standard process plan. Improvement in the customer satisfaction because you have reduced the lead time. So, classification build customer relationship can be done. These are the different impact group technology has on the production process. If you go back, we have seen what is the group technology implementation in 3 different phases. Action on manufacturing process we have seen, changes in the production process, and let us see the results that group technology have at the organization level is systematic design, and redesigning can be done very fast. High quality level can be maintained, lesser process planning time and setup time will be there, because there is already a standard process ahead laid in front of you. All you have to do is tweak that little bit up and down, and then you get to the matching output. And interestingly, many of the hotels, star hotels, follow group technology. They try to classify and put the preparatory items in a ready-made fashion, and they have a standard procedure. They just follow the procedure, they get the output whatever you want. And they also follow a modular concept so that they can meet out to lot of customers. Now, let us move into the part family. A collection of part that possesses similarity in geometric shape, size, or in processing steps used in their manufacturing is called a part family. A part family are a central feature of group technology. There are always differences among the parts in a family. One family parts. There is a difference between P1 and P2, but they are all together. For example, all cylindrical parts as one family. The diameter can change, the geometry can change, it can have a step, it can have a thread, all these things. Part to part variation is there, but overall there are some similarity. But the similarity are close enough that the parts can be grouped into a same family. For example, you look at zoological family, which I was always telling, we call tiger, right, lion, then cheetah, etc. as cat family. Look at it, 4 legs are there, and we put all of them, they have a tail, all of them, but individually if you see, all these fellows have different in their variation. So, family is some similarity, but part to part you can have variation. What are the different ways to identify part family? First is intuitive grouping. Using best judgment to group parts into appropriate families based on the part or photo of the part. This is the first way of identifying a part family. The second way is part classification and coding. The third one is going to be production flow analysis. In intuitive grouping, we try to judge a group of parts into an appropriate family based upon the parts. Then part classification and coding, the second way of identifying the family, identifying similarity and differences among parts and relating them by means of a coding scheme is part classification and coding. The last one is using information contained on root sheet to classify into a family. So, this is called as production flow analysis or PFA. So, these are the ways of classifying a part family. First one is you look at the part, you know, okay, there are similar, so then you try to do by visual. Next, you have established a set pattern of coding, you look into it, where does it form and how does it form, and then you classify. The last one is based on some manufacturing process. Part family, 10 parts, these are 1, 2, these are different parts. Have you seen it? Pretty interesting. Or I have put 10. Okay, here is a 10th fellow, a short fellow. So, you look at it, all of them completely various, right. So, there are 10 different parts. Their sizes are different, their shapes are different, the features are different, but you can still classify it under one family. What is that? They are all circular. So, now for doing all these parts, what you need a machine is minimum a lathe machine. Then in the lathe machine, you can try to have holes made, grooves made, taper made, right. So, all these things can be made in a shaft. So, if you want to make a hole, completely drilled hole, then after this lathe machine, you have to go to a drilling machine. Then when we have to flat surface on a cylindrical surface, naturally you need a milling machine. The 10 parts are completely different, but they are classified under one group called as, maybe I can call it as a turning group. Every part can be made in a lathe machine or in a turning machine of a CNC, right. So, here if you see 10 parts are different in size, shape and material. I have not talked about the material, assuming that, let us assume these are different colors. So, this is copper, this is copper, this is copper, rest all are aluminum or steel, but the part family does not look at the material at all. So, it can, the 10 parts are different in size, shape, material, but quite similar in their manufacturing process. Okay. All the parts are machined from a cylindrical stock by turning. Some parts require drilling, some parts require drilling and milling or only milling after turning. Here is a part family. This is all a part family. So, traditional process layout is also there. So, what happens is, you see there are turning machines, there are milling machines, there are drilling machines, there are grinding machines, and of course, there is a assembly, correct. Turning, milling, drilling, grinding and assembly, all are there, right. So, now in this what happens, the part tries to flow from turning to milling, milling to drilling, drilling to grinding, and then it comes to assembly and then goes out. So, here if you see, the machines are grouped based upon the similarity in the manufacturing process. If I draw and if I want to write the entire thing into different work centers, I will just write it like this: turning work center, milling work center, drilling work center, grinding work center, assembly station, in and out of, or I can state as stores. Now, I have grouped them based upon the similarity in their machines, right. So, this is the traditional process layout. Now, when we talk about cellular layout based on group technology, if you go back and see, there is a zigzag or back and forth movement of materials which goes between machine to meet out the output. So, now what I have done is, I have wisely made several groups. So, what I have made is, the grouping is being made depending upon their part family. Okay. So, this is one group. So, wherein which you will have turning machine, milling machine, drilling machine and an assembly station. So, you will have a second group wherein which your turning machine is removed, you will have milling, drilling and grinding leading to an assembly. So, here what I have done is, depending upon the part, the features whatever is there, I have developed a layout. So, based on the layout, how have I done? Looking into the parts. So, now the parts, the machines are grouped depending upon the part. So, here this is called a cell layout. So, basically like your cell phone, we also call it as a cellular layout. In cellular layout, the grouping of machines have happened only in the fashion that what are all the parts which can be made, which is different from the previous slide. In previous slide, we have grouped all the machines which are similar. Each cell specializes in in producing one or a limited number of part family. The another big advantage is, suppose if you have established 3 lines like this of the same group of the machine, one machine conks off, the other 2 groups will be able to take the load and you will be able to make the output. So, cellular layout is a new concept wherein which we are grouping machines based upon the part to be produced, producing one or a limited number of parts in a part family. So, the next one is part classification and coding. Classification and coding is very important. Identification of similarity among parts and relating the similarity by means of numerical coding system is very important. For example, when a student joins a college, he is being given a roll number. As far as the college is concerned, the college does not have any value towards the name of the student. Till he graduates, the system identifies him only by the roll number. So, now in a roll number you can have 6 digits, you can have 10 digits. Like your bank passbook number, initially we had only 5 digits, 6 digits. Today it has increased to 13 digits. So, what is that? It is nothing but converting an individual's account into a unique number, so which is being given by the numerical coding system. That is what it is. Why? Because as and when the new entry comes into the bank, based upon the coding system what he has established, he will try to add the member into the banking. In the similar way, what we do is we try to classify and code every part which comes into the factory for manufacturing or assembly. If you try to take a car, there are minimum 10,000 parts. So, having a record of 10,000 parts by name is going to be tricky. So, what we do is we convert all the names into numbers. So, that numbering is called as numerical system. So, that is given by a coding system, that is called as numerical coding system. Most time consuming of the 3 methods is giving the number code. Must be customized for a given company or industry. It cannot be generic. For example, college to college, the roll number designation will be different. Some colleges have 10 digits, some colleges have 4 digits, some colleges have 13 digits. Earlier banks also used to have 4 digit number, 3 digit number. I used to remember my father had a bank account number of only 2 digits. Okay. But that was a era where we did not have an online transaction to happen. So, now it has all become online. So, now all the banks have to follow a unified system. So, they have 13 digits. Okay. So, the most important thing is to identify a coding system and follow that coding system. First time if you have implemented, then it becomes easy for a newcomer to take over. But what are you supposed to do? You are supposed to customize every coding system for that particular bank or for that particular industry. So, must be customized for a given company or an industry. The reason for using a coding scheme is design retrieval becomes easy, automating the process plan becomes easy, and machine cell design can also be done easily provided we have a part classification and coding system in place. The features of a part classification and a coding system are: most classification and coding system are based on the following attributes. One is part design attribute, the other one is part manufacturing attribute, or it can be a mix of these two, both design and manufacturing attributes. What is manufacturing attributes? Manufacturing attributes are nothing but threading, drill, hole, then bore. Okay. So, these are all manufacturing attributes. Design attributes can be tapered shape, a hemisphere to be made, and all those things. So, what are all the part design attributes? Major dimension, basic external shape, basic internal shape. This is what is called as aspect ratio. Then material type, part function, tolerance and surface finish. These two terminologies are different. Please clearly understand. This talks about the smoothness of the surface, and this talks about the machining process to be followed. Okay. Tolerance and surface finish, these are the part design attributes. If we want to look at manufacturing attributes, they are major process, operation sequence, batch size, annual production, machine tool, cutting tool and material type. You see, material type is common for both, but this is how a part is classified looking into the manufacturing attributes. First we saw about the part design attribute, now we saw about the manufacturing attribute. You can have a combination of these two, and that leads to a hybrid system wherein which you can have some 10 digits, where 10 digits you will have half of them follow part design and half of them follow manufacturing attribute, part design attribute and manufacturing attribute. So, this is what is the third classification. So, based upon that, we have three different coding systems which are followed. I gave you an example of a bank, they follow a coding system. You look at post office where they have the PIN code is code, then you will have a credit card where again they have a coding system, how many digits, whether to have alphanumeric. You try to take the PNR for the train, so they will have so many digits which are fixed. You take the PNR for flight, it will be there. So, all these things are examples of coding system, and they will all be unified such that it can be accepted by any system. Okay. So, when the same way, when we take the analogy in manufacturing, we try to talk about three different coding systems. One is called as hierarchical coding system or monocode system. The next one is called as attribute or a polycode system, and the last one is a mixture of these two, which is hybrid or mixed coding system. So, in hierarchical or monocode system, we try to follow a decision tree. So, hierarchical or monocode system follows similar to decision tree what we use, then used in design department. This is monocode. Attribute or polycode retrieval is very easy, used in manufacturing department. So, hierarchical common in design, attribute common in manufacturing, and a mixed is a combination of these two. These are the different coding systems which are followed in real time. So, there are three major structures in monocode. Monocode, a code in which each digit amplifies the information given in the previous digit. So, here if you take an example of 208016, which is the pin code of Kanpur. So, each digit will try to add information to the digit which is following that, or I should say this digit gets more information from the previous digit. A code in which each digit amplifies the information given in the previous digit. It is difficult to construct because when you have a 13 digit, it is very difficult to do. It provides a deeper analysis usually for permanent information. That is why I said for a post office or a bank we can do. So, difficulty to construct monocode is there, provides you have to have a deeper analysis of the complete part. and then it gives you a permanent information. When we talk about polycode or a chain type structure, each digit is independent of all others, presents information not dependent on the previous. For example, the same pin code 208016, individual digits has information which has no relevance to the previous digit, but in monocode each digit will try to get information from the previous digit, or amplification of information is done from the previous digit for the current digit. A mixed mode has some digit formed in polycode but strings them together in the general arrangement of a monocode and a polycode. Okay. Mixed code has some digit forming monocodes but strings them together in the general arrangement of a polycode, that is a mixed code. Okay. So, we saw 3: monocode, polycode and mixed code. So, let us try to understand the coding system. How does it happen? You will have a population space which is P, and then you will have a code space. So, this is H and this is code space, and you will have mapping everything into the code space. So, mapping from population space to code space. So, mapping, this is what a coding system does, mapping everything into a coded space. So, every part which comes into the factory can be given a number. So, the hierarchical coding system example, you can see 3 to XX is there. So, hydraulics is 3 to 1X, and if it is electrical it is 3 to 3X. So, again here you will have 3 classifications: 3231 is powered, 3232 is transmission, 3233 is receiving. And when we talk about mechanical, again 322. So, if you see that 1 is hydraulic, 2 is mechanical, 3 is electrical. Then the next X, which is again 1, 2 and 3, is thus power, transmission and receiving. When you try to talk about 322 mechanical system X, 1 stands for no thread, 3222 stands for unified thread, and UNC thread is 333. So, you can see here hierarchical coding system is followed. So, every digit tries to take an information from the previous digit. So, in hybrid you will have first 3, this is just a representation. So, you will have polycode followed in the first 3, then you will have monocode followed in the next 4 digit, and next again you can have polycode which is followed in the last 3 digits. So, here is a mixture of polycode and monocode. Polycode, every digit has its own relevance. In monocode, the amplification is happening of the information. So, generally there are several coding systems which are available. So, here are some of the coding systems which are very well talked about, and the most common thing which is generally recommended or most exhaustively used in factories are Optis code, which was developed by US people, and it has 9 digits. We also have so many other codes. For example, IAMA, Japanese, they have 8 code systems have been developed, and Gildemeister is developed by again US. Toyota in West Germany, they have also developed some codes. So, when you look at Optis, which is a very commonly used, it has 9 codes, wherein which the first 5 forming the primary code, while the last 4 are the secondary codes. The first out of the 9, the first 5 digits you see here, they form primary codes. So, the first digit stands with respect to aspect ratio. So, here you will talk about up to 4 is rotational, 5 to 9 is non-rotational in the first digit. Okay. Next, where the features are external or main shape, that is the second digit it is there. The third, in rotation, internal elements what are they, in L by D deviation, again in rotating machine what are they, and main bore and rotational machines will come in digit 3. So, this is main shape, this is rotational shape, then it talks about planar shape, and the last one it talks about additional like gears or holes which are there in the system. So, all these things are the first 5 forming primary code, and the last 4 are secondary code, which talks about in terms of dimensions, material, then original shape, and then last one is accuracy. So, digit 1 stands for general shape of the workpiece, digit 2 external shape and relevant forms, digit 3 for internal shape, digit 4 for surface plane machining, digit 5 for auxiliary hole and gear. You see there? So, 5 digits are gone. So, any part which comes inside a factory from the designer, they look at the feature and just go giving this codes to the part. So, then the last we have seen diameter, material used, shape of the raw material such as round, sheet, casting, then workpiece accuracy will all be put together. So, you will have a 9-digit number wherein which this are secondary and these are primary code. And here from each digit will take a value from 1 to 9. So, you can see how many different options you can have for this coding system, and Optis is most popularly used, and in the similar way other coding systems are also used. So, when we talk about Optis coding system for this part, you can see this part. This part is a cylindrical part wherein which it is a step turn, you have a groove which is made, and then there is a hole which is drilled. Maybe this hole is for feeding oil, or it can be used for putting a dowel pin for locking this with respect to a shaft. So, there is a small recession given. So, maybe through this recession there might be some other part which is inserted. So, the dimensions are given 80 diameter of the larger diameter and 60 for a smaller diameter, a hole has to be done. The total length is 112. So, generally when the blank falls inside, the blank will have maybe 115 in length. The total diameter of the bar stock or will be 80 millimeter. From there we will do a step turning, then the groove is made, and for from the assembly point of view there is a chamfer also made for 4 millimeter, and then you have an angle of 45 degrees. So, and finally all the shaft is done. So, they do a internal drilling of this part, and then they turn the part, and then they do this counter boring or counter sinking, they do it, and then they also try to do the hole which is there in a separate drilling machine. So, all the 9 digits are interpreted numerically. Example of mild steel forged round bar is further demonstrated in using Optis code 111032302. The attributes are denoted as A1 to A9 for the round bar. So, let us start doing it. So, A1 is equal to 1. So, here the rotational part so, where the dimension 0.5 L to D greater than 3. So, it is A1. So, A2. So, you know it has already been written. What is the code? It is 111032302. A2 is 1, wherein which it tries to talk about the external shape element were stepped to one end. So, it is second digit, then third digit is again 1, 3, 1. Why is that? Because it has a internal shape where there is a hole to be drilled, which is smooth or stepped to one end. A4 is 0 because no surface machining, that means to say milling. So, A5 is, does it have a this thing? So, 5 digit, A5 is 3, where in which it talks about auxiliary hole radial. Okay. So, A6, so I will write A6 here. So, A6 is nothing but 2, which talks about 50 millimeter diameter D. Okay. Then A7 is equal to 3, which is nothing but material is mild steel, material MS. Then A8 is 0, which is nothing but internal form in the round bar. Then A9 will be equal to 2, where accuracy in coding digit, right. So, if you look at it, I have just gone back, taken this as an example, and I have tried to give a number. So, based on this number, we are trying to see how are the parts classified. Now, it is very clear for you, just by looking at the part, I will try to give the number. Why is this number very important? Because this number can be now mapped to the process plan. And every time when a component comes, all you have to do is pull this part number, so you can get all the details which will be given in the routing sheet. So, this is another coding system we have used just for your understanding. So, it is RhosoPraha coding system. So, it has 4 digits code developed by Rhoso. Each of the 4 digits characteristics the part of kind, class, group and material. So, it is another classification system, but OPTIS is quite common. So, you also have MIG class coding system. MIG class coding system is done by Metal Institute classification, which was done in Netherlands. Okay. So, various functions of MIG class were developed as standardized engineering drawing, retrieval drawing based on classification, standardized process routing, automated process planning and select parts to be processed on a group of machine tool. So, this is how it takes. So, you look at it, this one has coding system up to 24 digits. So, these are all optional if you want to use it, otherwise the main thing has only 12. So, it has 30 digits. So, you should be careful. So, but when you do 30 digits, you talk deeper into a part, but every time you will have to store a data, you will have to give 30 digits. The first 12 has standardized. These digits relate to shape, form, dimension, tolerance and materials and so on. So, D class coding system, I am just showing you different coding systems. D class coding system, there is no fixed code classification and coding system, but uses a computer software system to rapidly and efficiently traverse decision tree logic similar to MIG class. So, we have basic shape, forms, size, precision and materials. So, it is 8 digits you have. So, part coding by D class, you can say B round, then you can have 0 outer diameter, bore, then you can have form, size, precision and materials, stainless steel is used. So, MDSI is another system. So, MDSI is nothing but manufacturing data system developed by classification and coding by called as CODE, CODE, which has 8 digits, hybrid coding using primary classification and secondary classification. Now, coming to the last, what are all the limitations? Is this ultimate what you get out of group technology? No. So, there is a limitation in it. The cost of implementation is generally high with an outside consultant for necessary, since in-house expert on GT is rarely available. So, implementing GT is a costly episode, may not be suitable for factory where a large variety of products are there. For process industry and for a general purpose industry, this is not recommended. The entire production of the company cannot be put under GT and hence GT has to coexist with the conventional layout. Every time you can't go do a grouping, you will have to follow different layouts. There are too many GT codes in use. So, there is no one GT code which is used by everybody. So, from company to company the part number has to change. So, no point in implementing group technology. It is often difficult to conceive all the operations for a grouping of a component being taken care in the cell creation for it. The range of product mix in a plant may be under constant change, in which case the GT cells may need constant revision, which is impractical. So, every time it has to change, but if the number changes, it becomes very difficult for them to implement it. So, to summarize, we have seen what is GT, what are all the benefits of GT, what is part family, how to classify them, then what are the different coding systems, and later we saw what are the limitations. So, before we conclude, I would like to add a small assignment for you so that you can start looking into it. So, this assignment need not be submitted. Let us try to take vegetables which you buy in the market. You try to take a bag, and then dump all with vegetables, different types of vegetables, right. And now this is a mixed bag, all with vegetables. Now you close your eyes and now just by touch feel and smell feel try to form different types of grouping. That means to say vegetables of similar size, similar shape and aspect ratio. So, you should form groups. Close your eyes, just by touch and smell you can follow this, and after doing it you open your eyes, and you will see lot of mistakes. Now, correct those mistakes, okay, and then establish a common cutting process for a family. Okay. So, now this is what will happen in group technology also. You will try to group them, and once you group them you give a number, and after grouping them you will try to find out some small mistake. So, then you will correct it. So, now what you do is you try to take a fresh set of vegetables or something, or now you have done for vegetables. Now, you take fruits, apple, orange, all those things, and try to classify them depending upon the family what you have already established with the vegetable. Now, what have you done? First vegetable you have grouped. Now, open your eyes and then put it into the classification whatever you have made. Now, it will be so interesting to see. You will see an onion, you will see an orange. Now, it comes to a point, can we have a common cutting process for this family where there are fruits and vegetables? Now, this is what happens in a coding system, and we did this coding depending upon the size and shape. Now, you have coded 6-7 groups. So, give numbers to each group, that is what you are trying to do. So, if you do this exercise, you will start appreciating when a new part comes inside an industry, how are they trying to put it in a family and how are they giving number to the product. Okay. With this, I would like to finish my lecture on group technology. Please try this exercise so that you will appreciate the difficulty in the group technology establishment. Thank you.